In my conversation is recorded. All right. So we know the problem already. Again, the problem is called 3 resistors in series. We've done it several times. I'm going to put my White Sox hat on because that means game time, right? So you have the equation, right? This is for equivalent resistance. And this is in terms of a series circuit. For a series circuit, right? And that equation looks like this. It's Req is equal to R1. And we got 3 resistors. So R2 plus R3 plus dot, dot, dot. And then, guys, chill out. The conversation is going to be picked up, and then I got to snatch points from y'all because y'all playing. All right? Okay, it's cool, it's cool. All right, so again, these arrows, and you don't know what they mean, it's just me telling you what they are measured in. And I'm moving as fast as I can because I know it's almost time for us to close. So ohms, and the other way to write it, you see, is omega. Okay? So next, they just walking in.
All right, say it again.
Yeah,
you can sit them down. You can sit them down.
Ohm's law.
All right, yeah, coming down. How many people we got to work on?
And that's voltage is equal to current multiplied by the resistance. Or epsilon, that's not E, that's known as the Greek letter epsilon, is equal to I times Req. And before you ask me, do I gotta write all that down? I'm just gonna say, do you want 100%? Because if you don't, that's on you. All right, so let's continue.
Did you already clear out the fire drum?
Known and unknowns. Okay. You helping them get this done, or they just okay? It's in the picture. No, I hear you. Talk is cheap, brother. That picture is not going fast.
I know it's in. He can't understand what you're saying.
No, he don't. You just gotta stop talking and stop cracking jokes. I'm just saying.
I know what's going on. I'm telling him what's going on.
Okay, I will see what he turns in though. Yeah, sound good, brother. Sound good. I'm gonna go off what you said. I showed him, but let's see what he turn in. All right, so because it's based upon our conversations. Now, what ingredients do we have in this problem, right? We got to look at the problem to see that. So we know that we have what's called a battery factor of 28.7 volts. McCord, are we leaving earlier?
No, I was just figuring I need service.
Because I heard over the radio, okay. I didn't know how much time I had. All right, 28.7 volts. Okay, you got to get caught up later. You're being called.
Derek.
I'm just going to take a pause, let him do that. I is this. Again, I'm redoing the problem, so you got your choice. Move too fast, look at that picture.
I need y'all to call me.
I know what you need me to call. Every morning. Alright, I got you. I got you. I'm coming. I got names in me. Look.
Okay, you got everybody, McCord? All right, back to what I was saying. Here we go. So these are your other ingredients, right? The resistors you needed, right? What, this one? That was from the problem, right? We cool? Okay. So then we got some other values. Again, I'm going to come around and see who's been doing work or who's just been chit-chatting. It's okay, because I got to tell staff who's doing what in class and who's not doing stuff in class. They're just using it as social time. We got two parts of the problem, part A and part B. I'm literally redoing the problem, so there's no excuses on getting it all done. But keep in mind, part B, you got to find out V2 and V3. So part A, what do we have? We have REQ we got to find, right? There's two parts of part A. Before you get to R3, some number in terms of ohms. And then you want to also find R3, which is what it's originally asking you for, right? And then part B, you're going to find a bunch of values. You're going to find V1. You're going to find V2. You got to find V3. All right? All right, let's rock and roll.
I'm back.
I'm literally redoing the problem from second period. It's 2 periods of robotics. So you can look at the picture, look at me. Either way, you got everything you need to get majority of the points. All right, so part A, what are we doing? You're solving for REQ, right, and R3 in this problem. And please do your subscripts. Make sure it's labeled correctly. All right? Come across. And we got to break down, like I said, Ohm's law before electromotive force, right? Epsilon. That letter is not E, it's epsilon. If you say you put E in there and be like, he gonna be all right. Well, I'm gonna need you to be all right when your grade is not tight. I'm gonna give you what you got. You gotta get it correctly. Just rewriting it. And we're gonna do some algebra on it. Right? And thanks, sir. Turn this way. If y'all need a recording, I will post it to YouTube and send it to you via SV if you need to watch me do this slowly or something. I don't know. All right, so what was I saying? We're gonna go into trying to get REQ by itself here. So do this. And then we're gonna remove I by dividing by I on both sides. Cross it out. Who said that? Yeah, flip it. Okay. That is 5 points. I'm like a straight Mortal Kombat character over here. You threw me off with the mask. I'll call you Sub-Zero. All right, now plug it in. You just plug it in the numbers you got there. And then this number too. Okay, now I'm gonna calculate using Google. What I'm doing time, 3:13, I'm not doing bad. So I use Google and I can just come up with a tab and say, hey, Google, make sure you type equal sign first to get Google to work as a calculator. So that'll be equals, let's take a look, we got 28.7 divided by 0.0567. We get a yield of 506.17. And that's omega. We're going to use this to next solve for. So next, we're going to solve for R3. So we're going to take this equation and do some algebra on it now. And then rewrite it again, right? And do some algebra on it. So I end up with this equation here. And all I'm going to do is remove R1 and R2 by doing the opposite of it. So that's going to be, and listen, y'all got to have these algebra steps in there or I will take points off. Do not cut corners. Okay, that allows me to cancel out some things and get R3 by itself now. So I can cross these out and I can cross those out. Let's rewrite our new equation and we can put the numbers in next. And then that all you gotta do after that is then plug in the numbers and calculate. So R1 was 248.33 omega. Please put your Greek letters in. Do not put weird numbers in.
Another class coming to the cell right now.
They're breaking it down. All right. I hear you. I'm gonna finish this part and we're gonna line up. And all I'm gonna tell you is you gotta finish your work. Who said that? Okay, Marvin, I think they talked to you. I hope you did more typing than mine did. That's all I'm saying. Yeah, because we had discussion. Yeah, you better have done your own work. Or I'm going to give y'all both an F. And I can tell. So be careful. All right, let me do this last part.
Got another class coming to the cell.
And I'm gonna leave it here for you to finish the rest. Now you got a part B to finish, and it's in the picture. I didn't calculate R3 because that's put in the calculator. Part B you gotta finish. All right, I need y'all to start signing up because I hear on the radio they starting to pull y'all one by one. You signed out already? Okay. If you signed out, I guess you can follow Mr. Rush.
Come back.
Sign out completely. If you don't, you'll lose information.